everyone, and welcome to a special audio-only episode of Talking Kotlin. My name is Seb, and I'm joined by my lovely co-host Márton.
Hi, welcome. So first of all, please, if you listen to this episode, do let us know somewhere. We have the Talking Kotlin channel on Kotlin Lang, Slack. You can, of course, find us anywhere on socials. This is an experiment, so we want to know if you listen to this format and if you enjoy it.
Exactly. And what we're going to do today is we're going to talk about the Kotlin 2.3 release, because there's been a bunch of changes in this release, and it seems that, if you're listening to Talking Kotlin on your commute, on your bike, wherever, and you would still like to get some information about this in an audio format, that having a podcast chatting about this might be particularly useful. So that's why this episode exists. We're looking forward to our feedback.
Yeah, let's look into some of the details. So let's start with the language bit, and here we can talk about features that were experimental in previous releases that have now graduated to stable. So one of these is support for nested type aliases, which means that you can declare a type alias within a class, for example. You can make it private and use it just within that smaller scope instead of creating it at the package, like top level, and polluting the namespace like that. So you can use type aliases in like nice small scopes. And then another feature which is now stable is the data flow based exhaustiveness checking for when expressions. So when you're doing something like handling all cases of an enum inside a function, if you've already handled certain values of that enum with a couple if statements at the beginning of your function, and then you want to handle all the rest with a when afterwards, you no longer need to add the branches that don't make sense anymore because they have already been covered by your previous code. So the compiler can see which cases you've covered, and you can just omit those in a when expression.
I think this is actually probably one of my favorite features to turn stable recently, because it really matches the overall philosophy of having short code, right, and not having to repeat yourself. And smart casts are great, and this kind of data flow based exhaustiveness checking kind of feels very similar to me, in that the compiler really just looks at things and just gets smarter at figuring out what branches are already covered and which ones are not. So yeah, having these throw illegal state exceptions in an else branch as part of your when statement or your when expression, that no longer being necessary is a huge quality of life improvement, if you ask me.
Yeah, this is also a huge theme for me as I'm writing Kotlin code, that whenever I look at code and it feels like the compiler could or should be able to figure out what's happening in it, then usually the Kotlin compiler actually figures it out, and it's another one of these cases handled very nicely. So then we have one more feature which is now enabled by default, which is return statements in expression bodies. So if you have a function that doesn't have a full body, but you're using just a single expression, previously you couldn't use the return keyword anywhere in there. And of course, this single expression might be somewhat complex. You might be using lambdas, lets, scopes, things like that. And maybe there are branches in there where you just want to do an early return for whatever reason. And now this is supported. So you can just use the return statement even if your function doesn't have a body.
I think especially if we're working with a lot of Elvis operators and this kind of stuff, now having that return somewhere nested as parameters or somewhere as part of a slightly more complicated expression just makes life a little easier.
Yep. So let's jump into our first big new feature in this release, which is going to be experimental, which is the unused return value checker. The core problem that we're trying to solve here is that when you call a function, most of the time you care about the return value of that function. And so if you ignore that return value, that's probably a potential bug in your code. And so the unused return value checker gives us a way for the compiler to check if you left any return values accidentally unused. There are functions where, of course, we don't expect those values to be used. For example, if something returns unit or nothing, then it doesn't make sense to report anything there because these values are not meaningful, so it's fine to ignore them. But the core idea is that for everything else, we eventually want the compiler to report a warning if you forgot to use it. So right now, this is still experimental and very much opt-in. And there are two modes that you can turn on using compiler flags. The first mode is check mode. And if you opt in for a given module with check mode, then the compiler will start verifying usages in your module for any function that we already know should be checked. So, for example, we started opting in things like the standard library and Kotlin X libraries into this system. So if you turn your own code to check mode and you have usages of the standard library there and you forget to use return values of certain functions, then you'll start seeing warnings for that. And the important part here is that it's always the authors of APIs who can tell their users whether a return value is meaningful or not. So over time, the entire ecosystem and everyone who's shipping APIs into it with libraries should add this information to their code and to their projects so that their users know whether a given call can be ignored or if it should probably be used. And so there are a couple different ways of doing this, of adding this information. You can start putting this information in your code very gradually with the must use return values annotation. So if you have a file or a class where you know that everything is must use, then you can add those annotations one by one. But ideally, you'll get to a point where you can turn on the full mode of the checker for your module, which will assume that all of your public API is must use by default, except again, things like unit and nothing returning functions. And then if you have functions where it's actually fine to ignore the return value because it's just some like auxiliary information that you don't need to use in every case, you just might want to also know whether like an operation succeeded or changed the state of an object, like something like that, like some small, like smaller bit of info, then you can annotate those bits as ignorable. So ideally you'll opt in your modules so that everything there is marked as must use. And for the functions that are special, which is probably like a small percentage. So it's probably like, I think we had some studies on this and it's like 15-ish% of functions that are ignorable. It was a number around that. So for those, you can mark them with an opt-out and tell users that they can be ignored. Does that make sense so far?
I think so, yeah. And then, of course, from the other side, there are scenarios where you might have a function that returns a value, but you as a user, for some reason, just really don't want to use it anywhere, right? So that case should also be covered. And this is where you can just assign it to a variable that's defined using an underscore or that's named an underscore. So you effectively just say, well, I'm explicitly doing a calculation or something, and I'm explicitly throwing away the result rather than just implicitly doing it and accidentally making a mistake here.
Yeah. And yeah, basically, like if you're calling something, for example, for its side effect, and you definitely know that this specific time you don't need its return value, you can do that. Of course, there's a lot of machinery in the compiler to support this. Because we have to figure out, for example, what it means that a return value was used. Obviously, if you take it and assign it to a variable or pass it onto a new function or call a method on it, then we know it's used. But there are more interesting cases, and the compiler is handling all of these. So the TLDR with this feature, I think, is that you first want to turn on the check mode of this feature, which will give you warnings for code that you're calling that already supports this, so that you can catch scenarios where you are accidentally ignoring return values. And then once you're ready for your own code to be all properly marked with this information, then you can turn this on in full mode. And then anyone using your code, whether you're shipping a library or people are just calling this from another module, actually even within a single module, this works. Then they will get the benefits if they have the checker on.
Now, what fascinates me the most about this is that, of course, we start using this kind of stuff before we put it out as part of our own code bases. And even inside of the Kotlin compiler, we found a couple of instances where exactly this kind of category of bug was caught by enabling this must use or unused return value checker, which is really useful. Like, there were situations where someone had a list and they added an element to it, but they used the version of the operator that would just create a new list rather than like creating it and assigning it. So the change wasn't actually propagated. And these are exactly the kind of problems that can be caught by using this feature. And I mean, it's also not something that's a completely novel idea, but Kotlin loves taking ideas from other languages as well. If you've ever touched Go, for example, you'll know that they have this feature built in as well, where the compiler will yell at you if you have an unused return. And in a lot of other languages, oftentimes you kind of try to emulate this as well, using perhaps like your linter or annotations or what have you. But having this as a standardized part of the language just means that you don't have fragmentation. And of course, we hope that as this change becomes more popular and graduates in stability, that it moves the entire ecosystem forward and to a slightly safer place.
Yeah, and what's worth mentioning is that while many languages have some kind of facility like this, you have two choices for what the default behavior should be, right? So things can either be ignorable by default, and then you mark every function that has something important to return so that its users get a warning about it if they miss it. Or you can have everything important and meaningful by default, and then mark functions that are actually ignorable. And since we found that most functions actually have meaningful return values in code bases, we are going with the approach where eventually we want the entire ecosystem and hopefully just all Kotlin code to be opt out by default. So everything is meaningful by default, and you just mark functions as ignorable return value if it's skippable.
I think this aligns pretty well also with what we nowadays consider to be good programming practices. Like, if a function returns a value, then ideally you should kind of aim to have that function be somewhat pure, perhaps as well, which enables you to work much easier with things like value semantics and so on. So it's I think a feature that really just nudges you to once again like write a little bit better code, which is precisely what I would want my language to do. Speaking of better code, Márton, I let me hear if this is a situation that you've ever found yourself in. You're writing some sort of class, perhaps it's a view model, for example, right? And you have you have some state in there, and probably you're using something like state flow to represent this. And you have this key problem that for external consumers of this class, you want to expose a read-only view of your state. But while you are working inside of the class, then you have to probably mutate the state. So you want the ability to actually update the state. That sound familiar so far?
Yeah, I think I've been doing this for like 5+ years. Like starting with things like live data and mutable live data, or somewhere around there.
I mean, I'm not surprised. And so how did you do this in up until now, I suppose?
Well, so the classic solution for this is what we call a backing property. So instead of having a backing field, which would just be the same type as your property, you actually create two separate properties. One of them is private and mutable, and then the other one is public and read-only, and the public one is just returning the same thing as what you're storing in the private one, but of course it's stripping the mutable type, so it's giving a read-only view into the private value.
Yeah, so this is the kind of classic pattern that if you've ever seen it in a class out there in the wild, is where you have a field that typically the convention has kind of established itself. You have a mutable version that starts with an underscore in the name, and then you have a read-only, and this one is private, and then you have a read-only version that is public, which specifies the type explicitly to be the read-only type, so it would be state flow of string instead of, mutable state flow of string. And that one just uses the get syntax to essentially alias down to the mutable version. This is a very common pattern. Like you said, you've done this for half a decade, and I'm sure many of our listeners have as well. And because it's such a common thing, we are bringing a nicer syntax for this to Kotlin as well. So now we have a new syntax called explicit backing fields. And with that one, you can do exactly this kind of split between the exposed API type and the type that you see from within a class without having to specify an additional private property. This feature currently is experimental, but effectively what it allows you to do is you can say something like, let's say you have a state flow that stores the name of a city. You'd write something like val city, and then you just say state flow, so the public type, and then you use field equals, and then you say field equals mutable state flow. So what that says is that the public type should be state flow, but the field itself that you can access from inside the class is the mutable version. So yeah, it's effectively a tiny bit of extra syntax that allows you to just express this without having to have multiple different properties. So also most likely things like refactorings might be a little bit nicer, and you just kind of save the extra boilerplate there. It is currently still experimental, so you need to throw on a flag, a compiler option. It's called -x explicit backing fields. I'm sure our listeners will look that up because they probably won't have this be me dictating to them. But yeah, it's a pretty cool feature.
Yeah, and it spares you from having to have that underscore everywhere in your code when you're accessing the private version, because through the wonders of smart casting, we just know what the actual type of that value is, and you can just write down the regular name of the property within the class, but it's magically mutable.
Yeah.
Something that we might want to point out here is that explicit backing fields do always return the exact same reference to the users of the class. So some people use patterns where they don't just return the exact reference from the public property, but they use a conversion function. Like for state flows, there's an as state flow function, which wraps your mutable state flow into a special read-only state flow, which doesn't implement the mutable type, so it prevents downcasting, and it makes it like extra secure, that no one can cast it back to a mutable type. But I would always argue that you have very different kinds of problems if your users are downcasting values to mutable.
I think this is, you're fighting a losing battle if you're taking this approach regardless. Because at the end of the day, if the users are so desperate, they'll start like whipping out reflection or something to fumble around in the internals. You have much bigger problems than whether or not they have downcasted one specific thing. Probably time to go back to the drawing board entirely. So actually, most likely, still a nudge in the right direction to just move to this new feature and not do this extraneous wrapping. The last topic that we'll be talking about in the language features category is our changes to context-sensitive resolution. If you're unfamiliar, context-sensitive resolution is the feature that intelligently figures out part of your qualifiers in your code. So for example, if you have a when statement and you're trying to match over direction.north, direction.east, direction.south, direction.west, you probably don't want to write direction every single time, because that can be inferred from context. And this is exactly the kind of resolution that happens here. So this is a feature that is currently still experimental, but we are continuously making changes to this, of course, to improve it. And of course, you are encouraged to try it out already. So we're on the road to making it more stable and having you manage a little less code again.
Yeah, and once again, this is one of my favorite features recently, because it just makes so much sense. When the compiler should know something from context, it seems like it could figure it out, it actually does know now if you have context-sensitive resolution going.
Yeah, I love not having to type direction dot for the 100th time again, or platform dot, or whatever other enums I might be working with. So much nicer to read.
Exactly. All right, I think we can move on from language features to things that are new in the standard library. The first thing that Kotlin 2.3 brings us in terms of updates is that the time tracking functionality that previously moved from the KotlinX datetime library into the standard library, namely the clock and instant types, are now in the Kotlin time package instead of living in KotlinX datetime, are now stable. So previously experimental, now these are stable. So you can use them for all of your time tracking needs just from the standard library without an extra dependency. Of course, the reason why we could move these into the standard library is that these are time zone independent types. So if you need to work with time zones, if you need types like local datetime, for example, you'll still want to use KotlinX datetime in your projects for that. To move to these new types, for the most part, is just using the new imports from the standard library, but we do, of course, have a migration guide in the README of the KotlinX datetime library. And you might have dependencies that are still transitively depending on the old types. So if you have those in your project, then you can pull in a compatibility release of KotlinX datetime that will make all of that work. And the last thing that is worth mentioning here is that if you are serializing the instant type, which is pretty frequent in API calls, then you will need KotlinX serialization 1.9 or later if you want built-in support for it, if you don't have your own serializer for it.
Very good. Next up in the standard library section are our new and improved features for UUID generation and parsing. Most interestingly, we have support for a new version of UUIDs in the standard library, and that's UUID v7. In case you're not familiar with UUID v7, there's a wonderful website called uuid7.com that lists all the wonderful reasons for why you should care.
I expected this website to list all version 7 UUIDs.
That would also be great. So looking at some of the key benefits of why UUID v7 is an improvement over its v4 predecessor is that these UUIDs are time sortable. So you can just sort them in increasing order based on when they were generated. They have precise timestamps. They are globally unique, which means that if you have multiple systems generating IDs independently, then you won't have collisions between those. And for the special case of working with databases, they also provide you with things like natural sorting, right? They can make indexes a little bit better because your database indexes can optimize kind of the storage and retrieval process. If you have distributed systems, you have unique sequential IDs that you can kind of create here without the risk of collisions, which are, of course, all pretty great features. So yeah, we've effectively updated the APIs a little bit. Beforehand, we already had a UUID.random function. That one does not change its behavior, so that will continue to generate version 4 UUIDs, but we now have two functions that explicitly generate the UUIDs of a given type. So generate v4 and generate v7. They're pretty self-explanatory. They just generate UUIDs. It's pretty good.
What I would add here with version 7 UUIDs is that the reason why they are easy to sort is because they literally start with the timestamp. So UUID is 128 bits, and the first, I believe, 48 bits of version 7 UUIDs are the literal timestamp. So those bits just contain a Unix timestamp as a number, but UUIDs are long enough that with all the remaining bits, these can still be globally unique, as you mentioned.
Very good. Great point to note. Of course, you might also find yourself in a situation where you might need to generate a v7 UUID for a given timestamp, and that's why we have the aptly named new function generate v7 non-monotonic at on the UUID type. Yeah, and this one, again, does exactly what it says on the tin. Why does it say non-monotonic at? Well, because it does not guarantee monotonic ordering. So if you have multiple UUIDs that are all created for the same timestamp, those might not be sequential. So don't rely on that. That's why it's specifically mentioned as the name.
This might be a contender for favorite standard library function name.
It's pretty good. It's pretty good.
It's almost up there with first not null of or null. Almost.
Likewise, if you're receiving UUIDs from other places, you might want to parse them into UUID objects in Kotlin. And for those, we have new functions that can return null instead of throwing an exception if the string is not a valid UUID. So there's parse or null, parse hex dash or null, parse hex or null. So for all the formats that your heart desires, we have those built in there as well. They behave exactly as you would expect. I think that wraps up the standard library quite nicely.
Yeah, and we should, of course, mention that all these APIs that we mentioned, whether it's the time handling APIs or the UUID ones, are multi-platform. So you can use these across any platform where you're running Kotlin.
We love that.
With that, let's go to platform-specific changes. For the JVM, we have a very brief one. With Kotlin 2.3, the compiler can now output classes that contain Java 25 bytecode. So usual, keeping track with Java releases. With that, we can immediately move on to Kotlin native, which has more and more interesting changes in it. The first thing that we should highlight here is that we now have faster build times for release tasks, which is always super nice to have. So with tasks like link release framework iOS ARM64 and similar, top contender for favorite Gradle task.
Yeah.
These release build tasks can now be faster in our measurements, up to 40% faster, which is a very noticeable improvement for KMP projects that you're building for iOS. And of course, we already have a documentation page that describes a whole bunch of tips for improving your native compilation times, which is always worth visiting if you haven't looked at it in a while, because there might be low-hanging fruit in your configuration or what you're doing with native that could actually make your compilation much faster.
I mean, the excellent part about all of this is, of course, also that, makes your CI faster perhaps as well if you're creating release builds on there, and a little bit cheaper, and it just reduces your overall time to artifact, which is always good.
And then sticking to the native part, we also have some new features in Swift Export, which is the technology that gives you nicer APIs when you are calling from Swift code into shared Kotlin library code. So what's specifically new here is enum support. So previously, when you had an enum defined in Kotlin, it would just be exposed as a regular class to Swift users. But now Swift users actually see these as enums as well. So these are now iterable. You can iterate through all the cases if you want and handle each of them. And you can also use things like the Swift dot syntax to access different values within the enum. So it kind of just works as you would expect enums to work across the language boundaries, which is super nice. And then the other new feature that we shipped for Swift Export is support for variable number of parameters. So if you have a parameter in Kotlin code, which is marked with vararg, which lets you pass any number of values for that parameter, then that becomes a variadic function in Swift. So again, you can call it just like you would call similarly styled Swift functions by just passing in multiple values with a comma-separated list.
Nice. Very good. We are also making changes to the ability to import C and Objective-C libraries into your Kotlin native projects. This has now been bumped from experimental to beta. So if you are using C or Objective-C libraries, you can rest assured that we're slowly moving that towards a stable release. For now, there are still a bunch of things that need to be annotated when you use your C and Objective-C libraries, but those annotations have not changed from the switch from experimental to beta. So if you're having Kotlin code where a lambda does not just specify the type, but actually specifies the name of the parameter as well. So if you have something like name : string and then arrow to whatever your return type might be, then these parameter names are now forwarded to Objective-C block types as well. So if you're using them in Xcode, writing some Objective-C, you can actually see them as part of the suggestions.
And this is something that Kotlin tooling already picked up. So adding names to parameters in your function types that you're taking as parameters has always been optional because you can just leave out that bit.
Yep.
But if you do name that incoming parameter in a function type, then if someone is calling your function and creating a lambda to pass into it, then tooling would pick up that information from where you declared your function and just give that default name to the incoming parameter to make the experience just a bit smoother.
Yeah. And before we move on, a couple of housekeeping things as well. The Apple target support is changing a little bit. The minimum supported versions of Apple targets with Kotlin 2.3 are bumped for iOS and tvOS from 12 to 14 and for watchOS from 5.0 to 7.0. I think the most important part that's also worth discussing here is that the macOS x64, iOS x64, tvOS x64, and watchOS x64 targets are demoted to support tier 3. I think this is a particularly unsurprising change. The entire Apple ecosystem has moved on to ARM-based systems by now, so all modern code is most likely targeting those and no longer requires the x64 targets as much. They're still around, but at the moment they are not guaranteed to be tested on CI, and there might be some other smaller things like source and binary compatibility between the different compiler releases might not be provided. Eventually being Kotlin 2.4,
hopefully,
we do plan to remove support for those x86 64 Apple targets completely.
Right. So let's look at Wasm next, where we also have some changes. So one of the first things that happened here is that fully qualified names are now available by default if you're using reflection on the Wasm target. So if you're reading the value of kclass.qualifiedName, then you'll actually get the fully qualified name of the class that you are inspecting. Previously, these were not accessible. You only got the name of the class and not the full package, the fully qualified name, because it just increased binary sizes too much to store all of that information in strings. But we have a new storage solution for strings in Wasm, which is that if a string only contains Latin 1 characters, which contains like 200-ish common characters, which is going to be essentially every like fully qualified name character, then we can use UTF-8 encoding instead of UTF-16. So we can make these strings much smaller. In our measurements on the KotlinConf app, for example, compacting Latin 1 strings decreased size by 13% compared to builds which didn't have this optimization yet. And then once we turn fully qualified names on, which of course increases the size a bit, we still had 8% smaller binaries than without both of these things. So with the new release, you can have fully qualified names with this new optimization, and your apps can still be around 8% smaller than they would have been in previous Kotlin versions, which of course is fantastic for web applications, especially because this impacts the loading and startup times and the initial time to content on the web.
Also on the WebAssembly side, the new exception handling proposal is now enabled by default for the Wasm target. So far, Kotlin for Wasm has used the legacy exception handling proposal, which is part of the WebAssembly standard. But at this point, most standalone WebAssembly virtual machines already have support for the newer version of this exception handling proposal. So now, starting with Kotlin 2.3, this is actually the default. So you get better compatibility if you're running on modern WebAssembly runtimes. I want to make it clear that this is a change that we're making to the wasmWasi target, which means WebAssembly code that is running in a standalone virtual machine. And in this scenario, that's a change that we can safely introduce because you're not running in the same diverse runtime environment that you would have with browsers. Instead, you most likely run on one single specific virtual machine that you as the user control. So you don't really have this problem with compatibility issues here. For the Wasm JS target, so when you are running in the browser, the new exception handling proposal remains off for now, but there is a compiler flag where you can turn it on if you so desire. Moving on from Kotlin Wasm to Kotlin JS, there's a couple new changes here as well, like exporting suspend functions to JavaScript, begin 64 array as the underlying type for Kotlin's LongArray, and a couple of other things. Márton, why don't you just take us in?
All right, so the first thing with JavaScript export is that you can now just export functions that are suspend functions in Kotlin. There is, again, a flag to enable this with compiler arguments, but what you get is essentially if you have a Kotlin suspending function and you put a JS export annotation on top of it, or the class that contains it, then that will now be directly exported to JavaScript, and it will become a promise on the JavaScript side. So you can use all of the usual facilities for working with asynchronous JavaScript functions there. You can, for example, await the result of the suspending function, as you call it, which is pretty nice. Again, this is experimental, so as with everything here, we are awaiting your feedback.
It's an extremely useful feature from, I think, a couple of perspectives. I mean, first of all, if you're building a library that's supposed to be used from the JavaScript or TypeScript world, then having this feature effectively means that you no longer have to manually write some kind of wrappers or anything like that. If you have built your library in a coroutines first fashion where you are exposing a lot of suspending functions, now being able to just have a TypeScript or JavaScript consumer call those directly is a lot more convenient than trying to maintain a promise wrapper manually, which is quite a delight. And of course, the other point, which I always love to mention, is that when we're talking about JavaScript, we are always also talking about TypeScript here. So you are actually getting the TypeScript signatures for the generated code as well for all your Kotlin JS code. So if your consumers are TypeScript projects, then for them, it effectively looks like any other TypeScript dependency that they are using, which is quite delightful.
Yeah, and then adding exactly to this, to make this interrupt nicer, we also have improvements to exporting long arrays. So if you have Kotlin code that uses the long array type, this was previously exported as an array of bigint to map this into types that exist in the JavaScript world. But we are now converting this into the bigint64 array type directly, which is a more appropriate type to use. And again, if you're calling this from TypeScript, for example, you can just see that more specific and more appropriate type and not have to worry about converting between the different array types as you're crossing language boundaries or anything like that. This is similarly experimental, so it also has its own compiler flag to turn it on.
We're also making it a little bit easier for consumers who are working across different module systems to access Kotlin declarations. Specifically, we're improving the way that you can access a companion object. Doesn't matter whether you're coming from CommonJS, from AMD, from UMD, whether you're not using any module system. Those terms might be a little bit scary for people who are not in the web world, but those are kind of like all the different iterations of the JavaScript ecosystem, inventing and reinventing module systems until finally landing on a somewhat standardized ES modules. implementation. Now, when you have some Kotlin code that JS exports something that has a companion object, then now you have the consistent way of accessing this. So where beforehand, sometimes you would say like class name dot function name, sometimes it would be class name dot get instance dot function name. Now for all of the module systems, it's just class name dot companion dot function name. So one consistent thing, and one that even looks very familiar to what you would write in your Kotlin code perhaps as well. This is really nice because it also has a cool side effect. It also fixes how collections can be interoperable, because beforehand having the collection types being accessed was different based on the module system that you were using. So you might have to write ktlist.fromJsArray in some of the module systems and ktlist.getInstance.fromJsArray from other module systems. Now everything is consistent. It's just ktlist.fromJsArray. You have one consistent conversion function here. This feature is already enabled by default, so everything's good.
Yeah, and I guess this is quite nice if you are not on ES modules yet, but you'll eventually want to move to them. So whenever you like move between different JavaScript module systems, you won't have to change the code that's calling into Kotlin, because all of them will now look the same. The next one is that you can now use the JsStatic annotation in a companion object that is nested in an interface. So previously, you could only mark things with JsStatic in companion objects if they were inside classes, but now the same thing also works if you are putting that companion object just into a plain interface. And this again is going to be accessible. These static functions are going to be accessible with a common API across all module systems. So it's just class name.function name, and that's it. Because it's static, right? You get the static syntax.
Makes sense. And there are some other key conventions in the JavaScript and TypeScript worlds where Kotlin 2.3 is now slightly better aligned. Specifically, I'm talking about default exports. Now, previously, we did not have support out of the box for supporting JavaScript default exports in Kotlin code. So getting some sort of like export default and then a class name, which is kind of what you get if you import that thing from a JavaScript or TypeScript file without further specifying what object you want to pull out of it. Hope that makes sense. We kind of did not have support for this. We only generated named exports. So that would also make the import a little bit more annoying. Now you could kind of work around this using like a somewhat ugly hack by saying like @JSName and then putting in default space. And because the compiler did string concatenation at some point, this would happen to work, but it's really scary. So now we just have a proper annotation for this. You could just write @JSExport.default, and when you apply that to a Kotlin declaration, doesn't matter if it's a class, an object, a function, a property, then the generated JavaScript automatically includes that export default statement for your ES modules. There are nuances to how this works in other module systems, but you should really just be using ES modules by now. Most importantly, this really helps you with integrating with any platforms that expect default exports. That's like Cloudflare workers, frameworks like React.lazy. We've enabled this feature by default, so you just use the @JSExport.default annotation. Hopefully get rid of any of the string concatenation hackiness that you might have had before.
And then to wrap up the platform-specific changes, we actually have an Android-related change from the Kotlin side. So the Compose compiler can now output ProGuard mappings for compose stack traces if you are minifying your apps with R8. So if you have minified release builds, you can now get ProGuard mappings for getting better debugging information after something crashes in your Compose code. Because Jetpack Compose executes your code in multiple phases, and these are executed separately. Sometimes crashes can be quite difficult to debug because the stack traces are not necessarily pointing you to meaningful places by default. But now with an opt-in API, which was previously available for debug builds and now also possible for minified release builds, you can get better location details. Because the compose runtime can detect that a crash has happened and then reconstruct the stack trace for you and give you something readable that will point you to a more specific point in your code. So the new API for this is composer.setDiagnostic stack trace mode, and then there are a couple different modes that you can turn this on with. You can take a look at the documentation to figure out the exact details of when you might want to enable it. But the point is that it is now easier to debug crashes that happen in minified builds that are running Compose.
I'm all for having better diagnostics anywhere. Okay, well, I think we're almost through here, so I think our listeners deserve a little bit of a treat. It's time to talk about breaking changes and deprecations, everybody's favorite.
Oh yeah.
Luckily, there's not that many here, but there are still some that are noteworthy. The Kotlin 2.3 compiler no longer supports language version 1.8, and on non-JVM platforms also does not support language version 1.9 anymore. But we are already in Kotlin 2.x land, so get with the times. And probably the most significant change, support for the Ant build system is no longer available.
Oh no.
We still supported Ant?
That's incredible, actually.
That was kind of incredible. And of course, as the language evolves, so do our learning materials and documentation. A key point that is different now is that the Kotlin multi-platform documentation is now completely included as part of the documentation offering on kotlinlang.org. So you can switch between Kotlin and KMP docs in one place. That comes with all the updates that are required for that as well. We've made a whole bunch of changes as part of the Kotlin documentation. The ones that I do want to shout out the most, though, are those related to coroutines, because we have reworked the coroutines basics page as well as the page for cancellation and timeouts. Both of those are pretty key if you want to understand how to work with coroutines effectively. And these new materials hopefully make the start a little bit easier. But even if you're already an experienced developer, now might be a great time to take another look at them and see if the mental model that you've built up matches how we are teaching coroutines nowadays.
All right, with that, I think we're about ready to wrap up the episode. So let me highlight some final timely things that you might be interested in. So first of all, KotlinConf is coming up in May. We're going to Munich this year. Well, I guess some of us are already in Munich.
I'm not going anywhere.
And you can also join us at KotlinConf still. Tickets are on sale, including workshops. Both of us are also participating in workshops there. So you can have a look at those offerings.
And we also have the Golden Kodees Community Awards going on, which you can check out on the website as well, which is linked. It's our way of celebrating some of the people in the community. So please do give it a look.
Once again, this was a special audio-only episode, and we would love to hear from you if you made it all the way through the episode. If this worked for you, if you have any feedback on it, and if you would like to hear more, for example, covering release notes in this format. You can, as always, find us on the Kotlin Lang Slack, in the Talking Kotlin channel, as well as all over socials.
Yeah, and please actually do give us a little note, because obviously we're trying this for the first time. We want to see if this resonates for you. So write us a short message. If it does not resonate with you, don't write us a short message and we'll also get the hint. So either direction works. But if you would like to see more of this, a short note to us indicating that would really help us judge whether we should do more of these. Well, I think that's it. That was Kotlin 2.3. Of course, we hope that you have a lot of fun with all the new things that are in this release. And we hope that you will tune in to the next episode of Talking Kotlin. All right. Thank you for joining us today. And until next time, have a wonderful Kotlin. Take care, everybody. Bye-bye.
Bye.